Probably a good idea everybody goes on to mute while Ed's getting set up and talking.
Okay, is that okay? Can you see my slides?
Yeah, looks good.
Okay.
We're good.
Okay. I am not a big fan of Zoom. I'm usually a face-to-face person, and I hate talking to the wall. That's no negative comment about you, but it's really not. It's so impersonal. I can't stand this thing. So I'm hoping that we go back to the point where I can show up face to face. Anyway, I'm here to talk about something that I've been interested in since the 1970s. And it's the appearance of infectious diseases that we have never seen before. And by the time about a year after I became interested in this, uh, it occurred to me that we have to figure out why this is happening, because it happens on a regular basis. New diseases show up literally almost every year. And in fact, there are multiple diseases in some years, including this one here. And we're only into April of this year, and we've already seen 2 new ones. So I started thinking about this, and the answer became very obvious. It's because we have changed the world. Humans have changed the world, and that's the topic that I would like to discuss with you. Now, I was trained in the 1960s, and in 1967, William Stewart was the Surgeon General of the U.S. This is the person who is in charge of making public health policies, and it scared me when I read what he said. He said, "The time has come." This is 1967. I was just starting my graduate program. The time has come to close the book on infectious diseases and declare the war on pestilence won. We have basically wiped out infection in the United States. And I'm thinking, can I find a job after I go through this training? And it turned out many years later, not too many years later, Stewart claims he never made that statement. And it doesn't matter. The fact is that I have never looked for work. The work came to me. So let's look at what the situation is really like. In 2016, these are the top 10 causes of death in high income countries. That includes, obviously, Canada. And the bars are, the length of the bar is important because that tells you what the death rate is. The longer the bar, the more people die from it. And it turns out these are the top 10 causes of death, and they're color coded. So it's really easy to see what we're talking about. That the only, for my talk, the only thing you need to look at is the other red bars. Those are communicable or infectious diseases. Lower respiratory tract infections were the only infectious cause of death in 2016 that hit the top 10 list. Okay, and by the way, this has not changed. It's always been among the top 10 uh, uh, ever since records have been kept. And it turns out William Stewart was probably partially right if you don't look over the fence at low income and middle income countries. We used to call them developing nations. We now go on the basis of their by their income. Now look, look at the red bars. Infectious disease runs rampant in low income and middle income countries. And so there's no end to work for people who know something about infectious diseases. So I want to talk about new diseases. By the way, lower respiratory tract infections are a combination of bacterial and viral pneumonia, influenza, and now COVID-19. Okay, so And so this was in 2016, the latest information that the World Health Organization could compile. This is going to change dramatically. This is still going to be number one. And my suspicion is that when you go to the high income countries, this is going to go up a bit. And because of what COVID-19 has done in the last year. So this, the lower respiratory tract infections is the number one global killer. And when they look at 2021, this bar is going to go off scale. It's going to be that bad. So I want to look at new infectious diseases on a general scope, not just COVID-19. And in fact, this topic is not on COVID-19. I have a special talk on completely dedicated to COVID-19, where it came from, et cetera, what we know, what we don't know. But I'm going to focus on all of the new diseases which appeared since 1970. Actually, I can go back to 1945. But within the time span of my working lifetime, I have seen literally an average of one new disease every year. And everybody, this is my personal catalog. And everybody asks me, why did you stop in 2005? Well, 2005 was my penultimate year before legally enforced retirement. See, I reached the age of 65 in 2006, and I lost my job. They literally fired me because I was too old. So I keep on working. I've just simply retrained myself, refocused myself, but I've never gone back to this thing to keep this thing going. But it turns out if I can extend this this information out to 2021, that curve is still going up and it's never going to stop. We've already seen two new ones this year alone. So we are in a whole new world. I mean, I'm talking about diseases that never, never ever showed up until the years, the recent years. It's an absolutely amazing trend, never before experienced, except probably in the beginning of human existence. That's the only other time this has happened. So there were no epidemiologists back when time began. But we do have epidemiologists today. These are people that track infections, figure out where they're coming from, why they're coming, and how do we control them. So the modern age, I call this the modern age. I've lived in the modern age, and it turns out this is an epidemiologist's dream. This is the kind of stuff we're trained to do, and how I thought life was going to be awfully dull because we had discovered literally almost all the infectious diseases there was to discover. And that's basically what the message was. And it turns out it's to get new diseases was just a dream, and it's now turned into a nightmare. It's just not stopping. So we have to figure out what causes it. Now, in 2016, the situation was so dire in low and middle income countries that the journal Science polled 50 experts, 50 infectious disease experts, and asked them. See, we were worried about the fact that there were no controls, no medications to treat these diseases, and more importantly, no vaccines to control, to prevent them. So the World Health, the journal Science asked 50 experts to list in order, rank in order, the developing new diseases that we needed to develop vaccines for immediately. And what's amazing, so most of these you've never heard of before. The only old guys are hookworm, schistosomiasis, and paratyphoid fever. Those are the only old guys. And in fact, these, all of the others, all of the other 7 are red starred. The red starred ones are new virus diseases that we had never experienced before. And we were completely, in 2016, we were completely unprepared to deal with. And the names tell you a lot about their origin. Ebola, Sudan, chikungunya, MERS, Lassa fever, Marburg. In fact, among these red starred diseases, only one does not did not develop in um, Africa, and that's MERS, Middle East Respiratory Syndrome, which is related to SARS, and in fact is still, unlike SARS in 2001, MERS still goes. It hasn't disappeared. So it's joined COVID-19 as another SARS-like virus. So uh, if you look at this, we have a huge problem, and what's not even listed here is it's HIV/AIDS, which uh, is a new disease. 1980, believe it or not, in 1980, it has caused a pandemic which exists to this day, and we have no vaccine for that. I think the experts knew that the vaccine for HIV is still in development, and but it's not looking good, and so they decided to leave it off the list. I'm sure that's what the reason is. So I took this from a United Nations website. Uh, most of the diseases, in fact, uh, most of the diseases listed in my catalog are what a microbiologist would call a zoonosis. Zoo means animal, okay? And zoonoses are infectious agents, bacteria or viruses, that naturally live on or within animals, but which can be transmitted to humans. So 75% of all the diseases that we are seeing are actually of animal origin. COVID-19 is no exception, although we haven't identified the animal it came from, but we suspect it's a bat, but no direct proof. And 60% of all infectious agents, this includes the ones that have not, the ancient ones, are associated, in fact, with uh, parasites of animals. They live on animal, and they very often, in fact, most often, they do not cause disease and death in their host animals. But when they're transmitted to humans, an unnatural host for those pathogens, it turns out it causes severe problems. Certainly illness, and very often, like COVID-19, death. So zoonosis, important, I think an important word that you might bear in mind. Now, in the year 2006, Mark Wohlhaus, who is one of the world's premier epidemiologists, uh, said, it seems there is something special about modern times. These are good times for pathogens to be invading the human population. And, I had already thought this thing out, and I think the answer is we have changed the world. Let me show you how the world has changed. My working lifetime, I can block off in this red bar. These are years from 1950 to and projected or predicted out to 2050. And this is the world's population. And I think you all know the the population of this earth has literally burgeoned in the time frame in my working lifetime, actually. So it's doubled. See, we were about 3.5 billion people when I started my career, and it's now well over 7 billion, closing in on 8, in fact. So, uh, and here's the most amazing thing: in high-income countries, the so-called developed nations, that population, their share of this burgeoning population has remained relatively stable, unchanged, and in fact is predicted to remain unchanged uh, when we look at the population of the world in 2050. That's provided, of course, COVID-19 doesn't wipe out the US. And that is no joke. I mean, they are really taking a hit. And so in the light green and dark green What's represented there are the middle income and low income countries. So this burst in the in human population has occurred primarily in the least developed nations of the world. And go figure. I think you can see what the problem is, or maybe you can't. Let me give you one very simple, common sense problem they have. They don't have the financial resources for healthcare, public health measures. Uh, they can't purify their drinking water, and they can't get rid of. They can't take care of sanitary waste. And, I always look for a way where I can sneak this comment in. For 30 years, I advocated for sewage treatment in Victoria. We can't be a third world nation, and we kept on doing it until this past year. But we finally got it. And common sense, you don't pump raw sewage into pristine ocean waters, and we have destroyed the ocean out there. If you want proof, I have the proof. So, which the CRD, by the way, elected to ignore. Uh, so the second way we have, and these are human activities. We have literally caused population explosion. And another way we have changed the lifespan. Lifestyle in modern times. See, 1970, roughly about here. What we've done is we've increased global emission of greenhouse gases. What that means is the temperature, the temperature rises, and we have a global climate change. And, it doesn't help when you cut your trees down, because the trees actually eat up the carbon dioxide that we emit every time we take a breath. And so, deforestation, uh, uh, burning fossil fuels. What's interesting about deforestation, by the way, is you notice sometime around the year 2000, this thing is beginning to dip and going to level off. So maybe the way I view it is, well, that's very simple reason is that we have cut all the trees down. So by the time we reach at some point where this thing actually drops to a sane level, we will have no trees to cut down, basically. So the fossil fuel problem, let's face it, that's our problem. We have caused, and this is the real major cause of carbon dioxide emission. It's our fault. Okay, we have nobody else to blame. And once we destroy the forest, the next thing we do is we build on it. And go check on how much fossil fuel and CO2 emission is created when we build things out of concrete. Go check that one out. It's absolutely amazing. So we have created this problem. So remember who else is affected when you cut the trees down. It's not just global climate change, but we are taking away what used to be home for a vast jungle of animals. Okay, birds, you name it. We have taken the homes away. So when you cut things down, you not only promote accumulation of greenhouse gas, but you also destroy the homes of animals. You force them to live with you, and on top of that, because the population has exploded, we rely on factory farms, industrialized farming, and so we live in very close harmony with domesticated farm stock. We are also exposed more often to wild animals because we've taken their land away, their home away. And one of the craziest things I can think of is domestication of exotic pets. That's crazy. Even if you get it legally, we shouldn't be dealing with animals that don't belong in our household. And you see, the point is that these animals carry parasites. I have 2 dogs that live in my house, uh, and we exchange bugs. I know that. Okay, so if I brought in uh, really foreign stuff to join our menagerie, uh, you know, can you imagine what I'm doing? I'm exposing myself to things I've never seen before, and that's how a zoonosis begins. So all of this, the final outcome of this is contribution. All contributes to climate change. Now, I should also point out that there are more animals, domesticated animals, in this world than there are humans. Okay, it's that's what industrialized agriculture does. So we are exposing ourselves. These animals, and this is my my crowning feature of this talk. I'll come back to domesticated animals and what they're doing to us in terms of new diseases. So the third way we've tried, and I'm not trying to deny you pleasure in traveling. I don't travel. I don't want to travel. I feel much safer at home, and I'm firmly rooted to my home. So look, the problem is that we travel, and you can't stop this. We travel faster. We travel more often than ever before. So what this is a United Nations um, poll. It's a rough estimate of international tourist arrivals in different world regions. Now, color coded, and as a function of year. And as the years go by, more and more people are traveling to usually exotic locations. And I'm not denying them the pleasure of visiting places that are of interest. I'm not doing that at all. What I am saying is that we can't stop this. And these estimates in billions are taking into account what they call tourist arrivals. This is not business travel. Those people are also are more difficult to track, I guess. And so we're looking at something that uh, we we are seeing a continuing trend for over the next few years, and probably a long time beyond that. So here's the thing to remember: we take our germs with us, and very often we leave some of them behind. Uh, we also pick up new germs as we travel. We bring them home, and uh, therein lies maybe the basis for globalization of diseases that have origins in other parts of the world. So we're globalizing. We're sharing uh, diseases, and I don't know what else how else I can put it. So let me give you one example. It's an old example from 1980. 1980 was the first time we saw HIV. It was the first time we've experienced acquired immune deficiency syndrome caused by HIV infections. That was 1980. Now, I believe this figure comes from about 2016. So it's relatively old, but the number hasn't changed very much. 38 million people worldwide are currently living with HIV or also acquiring the endpoint of that disease, namely acquired immune deficiency syndrome. Okay, and so it's a pandemic. It's worldwide. A pandemic's a worldwide distribution of diseases. Epidemics are localized to small little regions. Pandemic means it's something that is truly totally globalized. And so how do we know where AIDS came from? See, there was some debate when the acquired immune disease syndrome, the loss of immune function, was first noted in medical patients. The hunt for the cause of that gave rise to this unusual virus that we've never seen before, human immunodeficiency virus, HIV. And it turns out, to find out where it came from, sent epidemiologists out into the field. These are guys who go out, literally go out into the wilds looking for the origin of HIV. And we had hints as to where HIV came from. We've, I think, early on, certainly by the 1990s, we knew that the birthplace of HIV and AIDS was Africa. So they sent epidemiologists into Africa looking for the origin. And this guy is taking a small blood sample. Yeah, it's a poke. That's the only thing the monkey feels. And it donates a small amount of blood. That blood is then sent to a laboratory where they attempt to just grow viruses. And out of that, out of those, so they went out and literally sampled all the animals they could capture in Africa. And they finally focused in on primates, monkeys, and apes. It turns out they found the source, and I'll show you the source in the next slide. But you see, these animals, how did the HIV jump from a primate into a human? And see, Africans rely on what they call bushmeat, which includes these primates. So they hunt them, they butcher them, literally butcher them, and they process them. And in the process, you can see no latex gloves back in those days, and no gloves. No gloves means that you will expose yourself to body fluids from these animals. And in these animals, HIV, the ancestor of HIV, lives in the is circulating in the bloodstream. So rare infections could happen if the virus in the blood of these animals could somehow get into this individual's body. And that's the way we think HIV infections in humans started. So this is a family tree, and it's complicated. So I'll just cut to the chase. It's based on DNA fingerprinting, nucleic acid genome fingerprinting, and the red letters indicate human HIVs, and the parents of those are shown in green. I'm sorry, shown in black. Okay, so the way this works is this is the root of that tree. There are actually two branches, two different HIVs. Okay, this is the most serious one. We call this one the one on this big branch. We call these HIV, human immunodeficiency virus 1, because in fact on the smaller branch, this branch here, they are a second related HIV, but very from the standpoint of its fingerprinting, DNA fingerprinting is very different from these. And the reason it is that these, the ancestor of these came from a monkey, the monkey known as the Sudi Mangabe monkey. The virus lived in these monkeys and accidentally infected humans at some point in time. And those red stars all indicate those accidental infections. So in the case of HIV-2, we call this the monkey version of HIV, HIV-2. This is if you ever had to get an HIV infection, this is the one you want, because this is the one which is, I'm not saying it's harmless. I'm saying it's least likely to be transmitted from human to human. And so this disease, in fact, HIV-2, is restricted at the moment, restricted to Africa. It's never left the African shore. But the only way it's going to leave is when an infected individual, either a traveler or a native African, leaves the country and carries it someplace else and then accidentally transmits it. But it transmits very poorly. So we think this one is pretty much the better of the two to have. This one here is very different. This one is a killer, and this is the one that is highly infectious, and this is the one which is now globalized. It's all over the world, HIV-1, and there are many different types, strains we call them. So there's type M, type N, type O, etc. And there's even one new one recently discovered, which we haven't even named yet. So, but I think what's really important to see is how many times these come from chimpanzees. HIV-1 comes primarily from chimpanzees, and so we think the chimpanzee version of this virus, the ancestor of these viruses, which doesn't cause any disease symptoms. I again remind you, in their natural host, these viruses do not cause any disease symptoms in their host. And so it's at these points in time, some human hunter hunted and killed and butchered a chimpanzee and accidentally became infected. That's happened at least 4 times that we can see, okay, just based on DNA fingerprinting. So we know where they belong on the family tree. We know exactly where they came from. And monkeys also carry their own version of the ancestor of HIV, but this one is very different. It's relatively tame. It doesn't seem to cause, doesn't seem to transmit from person to person as well as successfully as HIV-1 does. But we know where it came from. And we have, from these family trees, we can estimate approximately when in time these accidental infections took place. And we think it's early 20th century sometime. So if we can go back and look at the birthplace of just HIV-1, the birthplace is somewhere in Central Africa, this area here. And in fact, what agrees with this notion is the fact that this is where you find chimpanzees. So the DNA fingerprinting suggests that sometime in the early 1920s, the first infections of humans, accidental infections, happened. So at this time, this place was wild. It was just jungle. And it turns out individuals here didn't travel very far because of that. And so initially HIV-AIDS type 1 likely occurred as a localized epidemic. And then the problem started when I guess humans came along from other parts of the world and began colonizing these areas. And so Belgium, for example, took over the Congo, this area here, built a railroad of all things from here all the way down to Kinshasa, or what the Belgians call Leopoldville. And that allowed people to travel a lot, going all over the place. And so now, by the 1930s, you saw hastened spread of the HIV epidemic. The only people that saw it at that point were missionaries from Belgium who had joined the colony. Now it turns out, how did it get to spread around the world? Because this thing is so highly contagious. It turns out people from North America were sending aid workers, and the primary aid workers that were going into the Belgian Congo came from Haiti. And it turns out, apparently one of these Haitians became infected and brought it back to North America. He went home. It was a male. He went home, brought it with him to North America, and that began the North American epidemic, and it literally spread throughout the 1960s. By the 1960s, it was just going crazy. When they finally focused on what the disease was, they tracked down the notion that chronically infected individuals, long-term infected individuals, eventually lost immune function. They then looked around for the agent, the cause of that, and they found HIV. End of the story? Not yet. We haven't controlled this pandemic. Well, there's good news. What we have are drugs that prevent the virus from replicating. So it's a cocktail of drugs. Actually, you have to take a collection of drugs daily in order to keep the virus in infected individuals under control. So as long as it can't keep the virus from replicating, that individual will not be a source of new infections. So we have, and in fact, those individuals are living a long time now. And so the death rate has leveled off, and so has the transmission rate. And what would, I guess, heroes like Stephen Lewis from the US, I mean, from Canada, and the various other aid organizations in the world are trying to supply Africa with anti-AIDS drugs. And obviously, the big hotspot right now is in the Middle East and in the Far East. And we have to get the drugs widespread. We have to get enough drug to control the pandemic from spreading all over the world. So that's where we are right now. Now, switching gears, I want to give you one more example. Zika virus. Okay, this is another African disease. It originates from Uganda, and this is actually a website being developed and promoted by the Uganda Tourist Bureau. They want you to visit this wonderful tropical forest. It's a small, relatively small forested area, and they have a tour called the Uganda Safari Tour that takes you through this forest. And I don't know of anybody in their right mind who want to go through there. You see, what they have there are they say it's a nice tourist stop, right? And what they have there are 40 mosquito species that you can have personal close encounters with. They are actually primates here, monkeys and various other things. And the problem is this is where Zika virus, I think you have heard of Zika virus. Zika virus is the one that causes congenital brain malformation. Right? The brain doesn't develop in fetal humans if the mother is infected with Zika virus. Now, it turns out the reason I picked Zika is, see, a lot of viruses, the new viruses that we have seen, do not go from their animal source directly into humans. They need to be introduced by insects that suck blood. So the first animals that apparently had Zika were African primates living in the Ugandan jungle. And it turns out these mosquitoes, specific types of mosquitoes, need blood meals. So they feed, they suck their blood from these primates, and in that blood is a Zika virus. So the first infections were likely epidemics of Zika occurring in African primates, being transmitted continuously by the action of blood-sucking mosquitoes. Mosquitoes take contaminated, Zika contaminated blood from this animal, and then this animal, which originally did not have Zika, now has become a Zika carrier as well. So this cycle continues even to this day. Now, how did they get into humans? Well, a human tourist, no, actually, that's not a tourist. Africans live and work in the forest, and accidentally, this mosquito doesn't pick what type of blood it needs to feed on. So it will feed on human blood just as well as primate blood, whatever is available, and so it's infected. It eventually infected humans by uh, transmitting the Zika contaminated blood it obtained from primates into humans, and now we have this new cycle. We have humans which are infected with Zika virus. Now it turns out, so Zika virus was born somewhere in this area of the world, and it's now become pretty much globalized. And it turns out it's managed to make its way through the South Pacific and eventually into the Caribbean area. And this is where we began, North Americans began to encounter Zika for the very first time back in the 1980s and 90s, because these are favorite holiday hotspots for North Americans. And back here, most of these are native um, Pacific Islanders, and they were accidentally being infected. And you know, mosquitoes do not migrate. So how did they get there? Well, it had to be Africans traveling through uh, Asia, and uh, the same mosquitoes live there. So the cycle, the human mosquitoes driven cycle continues here, and people became infected, and humans from here probably traveled, island hopped all the way through, and pretty soon it was almost across the Pacific. Now, it's not the mosquito migrating; it's people carrying virus in their blood, which is actually causing it to jump across the Pacific, and eventually somebody gets up into some part of Central America and brings it there, and you have the human virus cycle. This took roughly 30 years to get across from one end to the other, but it's already across here. And now we have to worry about this because we have the mosquitoes up here, and climate change. See, mosquitoes don't like cold weather, but it turns out climate change is going to change this entire scenario. So I said 30 years. No, it's from roughly 1947 to 2016. Roughly in that time period, Zika has become globalized across the equatorial belt. It's a warm-loving disease simply because mosquitoes need that warm weather. Now the problem is that warmth is expanding in territory. So you can ask whether we in Canada have to worry about that. You know, we actually have the mosquito species that can carry this virus. And right now, the only people who come up with the Zika, and it's not just Zika, it's chikungunya disease, dengue virus. These are diseases you pick up usually by traveling into areas, primarily Africa. But you know, the fact is that these are now becoming globalized across the equatorial belt, primarily because this is the territory of the mosquito species that actually transmit these viruses. So all you need is a human traveler who is carrying these viruses into these areas where these mosquitoes breed in a completely new country, new area, and you will create a new focus of infection there. And then like, how do you cross the Pacific? Well, what individuals did was they island hopped and carried the virus all the way across the Pacific. And you know, we can see a Canadian visitor to an exotic site in Central or South America, bringing that virus home. And you know, climate change. If the climate ever gets up into that tropical area. And believe me, we are, on Vancouver Island, a prime place for these things to happen. I'm not saying it's going to happen. I'm saying that all we need is a few people bringing the bloodborne virus into these places where our mosquitoes can then feed and transmit that virus. And pretty soon we have a focus of infection. So I took this from the Canadian Communicable Disease Report. And there's a website there that warns Canadians, if you ever travel in these areas, you must be aware of this situation here. Certainly use insect repellents, and you know, I get approached by young people who not recently, who want to get married in some exotic place in Mexico, Central America, and they ask me about diseases like Zika, and I tell them, because if you are young, you're getting married, you plan to have a family, and you're infected with Zika, your developing fetus may develop malformed or ill-formed, actually, brains. And because it turns out Zika, one of the targets the Zika virus has in the human, especially in developing infants, is the precursor cell for growth of the brain. And so it catches, if Zika gets into a developing fetus, it'll attack that brain, the development of that brain. And that's what causes the problem. So I just before warning, I'm not saying don't go to these places. I'm just saying be aware of what it could be, or what you could be walking into, because climate change is real and it's going to only get worse. Okay. So everything happens in low and everything starts. All of these diseases start in low and middle income countries. No. Let me show you one example. There's several examples of diseases that have happened in our backyard. Here's one which I have been aware of, and it's one of my favorites because I actually did a lot of stuff with this. It turns out food infections are not ancient diseases. Food infections like salmonella, these are all caused by bacteria. Salmonella food poisoning, mid 1940s, first case, 1940s. And Campylobacter jejuni, most people don't even know this one here, can't even pronounce the name of it. This causes more infections than salmonella. That 1973, first case. E. coli 015787. This is everybody in your group and everybody in your household, all your neighbors carry E. coli in the lower part of the small intestine. That's a natural, it's a natural home for E. coli. But this guy is different. This guy has acquired a toxin, a toxic gene, okay? And it's so bad that it has a jail serial number. We call it 015787. 015787. And it's not the only one. There are now new strains with different jail numbers, okay? But the first one, 015787, happened in 1982. And Listeria monocytogenes was first discovered a long, long time ago, actually in the early part of the 20th century, 1900 something. But this one here is very different. Let me focus back on these three because and tell you where they come from. If just in case you don't know, Salmonella and Campylobacter started out as natural residents of barnyard poultry. The guts, these are gut bugs. They live in the guts of barnyard poultry, chickens, turkeys, ducks, etc. And they cause, this is the amazing thing about zoonotic pathogens. They don't cause any symptoms, any disease symptoms specifically in the poultry they infect. Nothing. And if they did cause disease, then we would like to recognize it and immediately exterminate that flock, and we would not see it transmitted to humans. The problem is that it gets into into the human food chain. And when we eat this stuff, if you consume this stuff, you will get deadly sick. Okay, and I should point out that if you ever get sick with these, you can't get it treated because antibiotics do not work. These are drug-resistant bacteria. So E. coli 15787 is a very special E. coli. Nobody carries this naturally. No human carries it naturally in its gut, in his or her gut. This one here developed in cattle, and it turns out uh, cattle were perfect because, in fact, the toxin encoded by this jailhouse number, that toxin uh, causes internal bleeding. So one of the clues to this food poisoning is if you have bloody stool, uh, and you know it's a food infection, it likely was this guy. It causes hemorrhaging in gut, with, and in fact, not just gut, but it destroys your kidneys. And it turns out this is the one that, look, 1982 is relatively recent. This one developed in cattle. So the earliest uh, disease outbreaks were in places that served um, uh, semi-cooked hamburgers. I believe White Spot in Seattle was one of them early on in the early 1980s. Anyway, this guy is so the question is, it's a gut bacterium, but when you process these animals, you remove that gut, and that gut is a single tube. The bugs are inside that tube. How does it get into the meat? And I'll let you dream about that, because, well, it's, see, uh, it should be obvious. Now, Listeria monocytogenes lives everywhere. It's in soil, water, air, you name it. It's all over the place. And this was never a foodborne problem. Never, ever caused foodborne disease until the 1980s when it showed up. Fortunately, this one here is relatively tame. It doesn't cause very many problems in healthy humans. If you're old, you're ready to fall apart like I am, or if you are a pregnant woman, then you have problems with Listeria monocytogenes. This one loves developing fetus again, so it'll destroy. It very often will destroy the fetus of a young, an early stage fetus. And in old guys, we just can't fight it off, so it overwhelms us. This is the one that caused Maple Leaf Foods to go almost bankrupt a few years ago, um, and uh, contaminated Maple Leaf Food lunch meat, which was served in care homes. And it turns out the people who were being affected were really old like I am, and ill prepared to get an onslaught of bacteria. But otherwise, this thing is very harmless. And but you will see food recalls. Whenever these things arise, you will see food recalls, and pay attention to them. The fact is that, there's no way we are going to monitor all the products that end up on our grocery shelves. We just have to rely on human consumers to be the canary in the coal mine. You know, somebody's going to have to get sick, and then the health guys the epidemiologists go out there and find out where it's coming from. It's the only way. So I'm going to wait till somebody else eats that stuff before I'm going to eat it. Now, here's the really bad news. It used to be that these two diseases only came when you consume poultry, undercooked poultry. If you cook the hell out of it, because bacterial protein is just as good. The bacterium has to be dead. That's the thing. But the protein in bacteria is just as good as the protein you find in the meat. Okay, cook the heck out of it. Do not eat anything semi-cooked, and especially this one here. You want to make sure you kill this thing. Now, these things. The bad news is that these things are no longer poultry, and beef associated. These three have become globalized. By globalized, I mean it's in everything from you can't be a vegetarian and say I'll never get these things because they contaminate uh, vegetable material, right? Fresh. I don't trust these greens that come prepackaged, pre-washed, prepackaged because they are very often the primary source. And in fact, you know, if they're being imported, and we rely on greens imported during the winter months, you have to watch out for those things. They're coming in from Mexico, places of. I'm not saying all Mexican stuff is bad. What I'm saying is that very often is the root of problems. Okay, so be forewarned. Now, how did that happen? You know, something happened in the early part of the uh, middle part of the 20th century on, and what happened was we turned to industrialized farming, and so this is the way we raise broilers. We crowd them up to the point where if this guy has a friend back there, he's never going to see that friend because you can't elbow your way through that pile. Same thing with cattle. This is the last feeding station, and they're not eating. By the way, they're not eating grass. They're eating high protein feeds, and because they're so crowded, infectious disease literally spreads. It doesn't take too much imagination for me to see that one chicken in this flock could have salmonella, and um, it's a gut bug. Gut bugs are excreted with manure. These other guys can go over there, peck at them. They're not sanitary. They peck at the manure. They get exposed. They become pretty soon the whole flock has the same infection. Same thing with the cattle. Okay, if you've ever seen these feedlots, if you haven't, go drive past them. You will smell the manure piles. Okay, so how safe is our chicken? Consumer Reports, and this is an old one from 2010, 10 years ago, 11 years ago. Uh, two, they just sample random. Go to any supermarket, grab, in this case, whole broilers, and they bring it back and they send it to a laboratory and they look for Salmonella and Campylobacter. 2/3 of those carcasses, I call them carcasses because that's what they are. 2/3 of the carcasses are contaminated with Salmonella and Campylobacter. That's how widespread this problem is. Okay, you can go any day of the week. You know, at UVic, I used to go up to Safeway. I used to run the undergraduate uh, laboratory. And the first experience they ever had sampling food would turn them off. They will not eat. I used to get hamburger, and it's amazing what is in hamburger. You don't want to eat hamburger. So look, what I'm telling you is that it's out there. The stuff is out there, and you can't cook salad greens, sadly, right? But you can cook the meat and cook it well. How did it get into the meat? Well, very simple. That tube that you remove um, during the processing must have broken. And they use sharp knives and they're working really fast because if you industrialize agriculture, you have to industrialize food processing. You get sloppy, things happen, and things have happened. So are you ready for the next pandemic? Well, it's coming. See, this is a recent paper, 2016, uh, uh, telling you about bats. You know, I just checked how many bat species there are on Earth. 1,400 bat species. And this group here looked at only a few of them, few species. And what they found was more than 200 viruses completely previously unknown in these small sample of bats they looked at. Um, why bats? Well, bats are becoming one of the most important reservoirs, homes for zoonotic pathogens. So COVID-19 is thought to be from a virus found in bats, but we haven't found that. We haven't found that critical link yet, and so still working on it. But I have a sneaky feeling that's the correct hypothesis. It has to be a bat virus. We shall see. And last but not least, look, if I kept my catalog of new diseases, I would be putting this one down. It's the second one this year alone. This one was reported on March 31st. Okay, we see this all the time. New diseases, never before. We have never seen this thing before, and they just keep showing up, and showing up, and that's the world we live in. Thank you very much for the invitation. I hope you learned something. I'll be very happy to answer questions, criticisms, anything.
Thank you. That was very interesting.
Fascinating.
Yeah. Could you unshare your screen, Ed?
Let me see if I can. How do I get rid of this thing? Oh.
I think you have to go back to Zoom. Yeah, there we go.
Yeah, Ed, I have one question. You were talking about deforestation is a big problem, and I mean, as we forest, we practice responsible forestry in British Columbia. We replant the trees, so are we talking?
Yeah, but I think the thing I'm not going to get political about this, but what I will say is this. You can replant those trees. It'll take a long time for them to catch up to where their original what their original parents look like. But the fact is that as long as you can do that, see, I'm talking by deforestation, destructive deforestation. I'm talking about the nonsensical cutting of trees. Like, look at the Amazon. It's that's a disaster. An absolute disaster. So I'm not talking about responsible tree harvesting. I am talking about the other guys that just
Right,
go
I understand.
literally rape these forests. And those are the ones we unfortunately, we have no control over these guys.
Right. Well, I also remember when I was a kid, like if anybody traveled to Hawaii, they were considered to be millionaires. So
Yeah.
so traveling has exploded exponentially. And that has to be, I see that's a big cause of transmitting viruses.
Yeah, you can get the virus, on a 4-hour. This one of these recent studies that I had fun with was a study done on a 4-hour flight on an airline, which doesn't need to be mentioned, doesn't need to be named. But it turns out what this guy was looking for was circulating viruses, because they recirculate all the air in these, and these people were masked, and they could find viruses. So in a 4-hour period. So yeah, it's risky. It's very risky.
Yeah, I think cruise ships are another topic.
Well, cruise ships are even worse, because look, it's like it's like a care home, assisted care home. Yeah, you can't escape, right? There's no
Right.
there's no way you're gonna get off that boat if something happens. And these norovirus outbreaks on ships are exactly like a norovirus uh, outbreak in a jailhouse, because you can't get off. There's absolutely no way. You can't keep yourself locked up in your room. That's one of the worst things that can ever happen. Get caught on one of them things.
Right.
I don't know if there's ever a solution to solving the globalization of disease.
So what
Ed, can I ask a question? Oh, sorry, go ahead, Barry.
What can we do other than being cautious and careful about where we go and what we eat, or are we're stuck here?
Well, you don't have to be stuck. You have to be knowledgeable. You have to understand, I think, you have to understand the circumstances. I am not saying don't travel, because I know people are going to travel and people enjoy traveling. People enjoy, it's their way out. And go ahead, enjoy yourself, but be aware of what the risks are out there. Don't be paranoid. I'm not saying, you could be walking the streets downtown right now, and it's just as dangerous as walking the streets in some exotic location, right? So you just have to be knowledgeable. You have to be aware of where you are and what the problems may be. But enjoy yourself.
Ed, can I ask you a question, please?
Sure.
First of all, thank you. This is amazing. The second of all, I remember when you came and talked to the rods and reels back in, what was it, 16 or 18 about GMOs? That was so interesting. Yeah, thank you.
Well, that story has changed, by the way.
Oh, good. I want to hear the update. How can we find out?
Yeah, well, the update is that, well, GMOs are not going to go away. I know people just want it to disappear into the woodwork, but it's not going to go away. Now they can make GMOs that are from the people who are on the side of for those who say it's unethical for humans to create GMOs. Well, see, the reason that they say that is that we're actually taking genes from two unrelated creatures and just literally transplanting that to create something that nature can't create. And that has been the opposition to this for a long, long time. So look, GMO salmon is a Canadian invention. What they did was took a growth hormone gene from a tropical fish and implanted that in Atlantic salmon. The reason is that the Atlantic salmon growth hormone doesn't work in cold water. So in winter months, it doesn't grow at all. But the tropical fish hormone is on all year round. So that's why those fish grow into monsters the way you guys may want to go. I don't know if you want to tackle those guys, but the fact is that we don't have to do that anymore. All we have to do is this new technique called gene editing. We don't cut a gene out of one source and then plant it in another one. So this is not cut and paste. What we're actually doing is seeing scientists just taking the genome of whatever organism they want to engineer and just erasing the code that they don't like and replacing the code with something they like.
So we're going to have you back to give us the whole detail on that one. That's a good one.
Well, you see,
can I ask a question?
Sure.
Can I ask a question?
I thought that was your question.
Well, no, I was just commenting and it was great, but yeah. I want to hear the details another time, but I wanted to also ask you about travel. And with COVID protocols, as we've noticed, there's less flu, less colds, less everything, because people are really being sensible about their proper protocols for health. I wonder, it'll be interesting to see how the cruise ships and the tourist destinations continue a lot of that more carefully, because they're going to lose tourists if they don't, and how that's going to look overall. I hear what you're saying. I'm not nullifying anything you said, but what do you think about that for the future?
Well, yeah, if there's anything positive to come out of COVID-19, and I hope people take it seriously. There's one thing positive. We have shown that we can control respiratory diseases that are transmitted from person to person by using two practices: distancing, social or otherwise, distancing and masking. Okay, and the seasonal influenza happens every year, like clockwork. And this year we saw no outbreak, no major outbreak. And it was just amazing. And what that proves is that masking works, so does distancing.
Okay? And washing hands.
Yeah, but I think for COVID-19, the hand thing is not as important as the other things. But the fact is that we can control respiratory disease by masking. But are we going to do it next year? I don't think so. Let's look at it this way. I will cut my hair as soon as this thing stabilizes. Okay, and I know I'm in there now for a really long haul. Okay, I know it's not going to happen very soon, and don't think that the vaccine development is going to be the thing which normalizes. People get a second shot and they say, "Wow, now I can go anywhere." No, you can't. It's not. It doesn't work that way. Okay, so we're a long ways out of this thing.
Yeah.
And so I don't know how long my hair will be by then. When you get old, your hair actually grows much, much slower. So that's the only saving grace. But I don't go anywhere, so I don't care what I look like.
Thank you for that.
Yeah.
I have a
Yeah.
question, Ed. Your autoimmune system.
Yeah.
I presume it gets worse as you age.
Yeah. Yes, it does. And the thing about the vaccine trials, all the vaccine trials that have been done, they have tested it in seniors, but the senior cohort is so small in comparison to the overall age distribution of the entire cohort. So I when they say it's 90% effective, I'm not sure if it's safe for me to conclude that it's 90% effective in and a person in their senior years. So that even in the senior years, what I do know is that not all individuals, individuals in that age bracket have comparable immune systems. So we're all different, and some of us are going to be okay, and some of us are not, and it's very difficult to tell where you belong, and that's my only worry.
Can you tune it up a little bit? Like I know someone who has a flu shot every year just to exercise his autoimmune system.
I get a flu shot every year, and I would like to think that's the reason I've never had influenza. But I'm not sure. See, the influenza vaccine is one of the problem vaccines that we have. It's not perfect, far from perfect. In a good year, it's about 45% effective. But and it's really doesn't. It sounds grim, but in fact, even at that level of inefficiency, it will protect you to a certain extent. We call it cross protection. It's better to have it than not to have it, is what I'm saying. I'm a firm believer that that vaccine is better to have than not have, even if it is not perfect. By the way, the perfect flu vaccine is undergoing trial right now in human clinical trial in Israel. I'm just waiting to see whether that's going to work. This is a vaccine which is far better than anything we've had for influenza. It's what they call the universal flu vaccine. It means you don't need a shot every year. You get one shot, and that shot is enough to carry you through several years, 10 years maybe, longer than I have left. But I'm looking forward to that day where we have a universal flu vaccine. COVID-19, I'm hoping that vaccine is a long-term thing. And right now, there's nothing that tells me, even with all the variants out there, nothing that tells me that it should not be long-term. So in other words, you get 2 shots, except for the one vaccine, the one shot guy. That vaccine should last you through several years at least. I'm hoping that's the way it is. Time will tell.
Okay, Ed, that was a fantastic talk.
Yep, thank you.
I hope we can get you back in a few years to get an update on how the infections are going. So stay healthy.